Alright, we're back. Having a little trouble with the tripod, but we're back. You need to ask your parents who wrote this song, who's singing right now. The name of the song would also be nice. Okay, let's get to number 4. This number 4 is going to be sort of hard, so we need to really get going here. So let's see. Using the above problem, that's problem number 3. Find the total money in the account at the end of 18 years. Okay, we know that there's $5,000 in the account initially. We know that at the end of 1 year, there's 5,000 times 1.1 plus 2,000 in the account. We know that this whole amount at the end of the second year will be multiplied by 1.1, and then we're going to add 2,000 bucks at the end of the year. This is the balance at the end of the second year. Let's do the balance for any year. So you're going to have, let me finish a sub 2. So if I do this out one more time, just so I can notice the pattern. You're going to have $5,000 at the end of 2 years. The $5,000 will have interest 2 times. The first $2,000 additional amount will have interest of 1.1 or of 10%, but times 1.1. And then here's your, at the end of the year, add another $2,000. So it seems like for any amount of years, you have this. 5,000 times 1.1 to the n plus, now it's 1.1 here to the n minus 1, because you're not going to get, for example, if n was, in this example, n's 18, the highest amount here is going to be 1.1 to the 17th. This is going to be plus 2,000, 1.1 to the n minus 2. Dot, 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 plus 2,000 times 1.1. And for the purposes of this problem, I'm going to ignore the last addition of $2,000. Okay? So at the end of 18 years, I'm going to assume my balance is my balance, and I'm not going to add an additional $2,000. Okay? So let's see. If I make this a little bit neater, I can factor out a 2,000 here, okay, and I'm going to be left with this is a geometric sequence, or geometric series. So the question's asking us to find a sub 18. Well, here's my initial $5,000 investment. It's going to get 10% interest over the course of 18 years, plus, I'm going to rearrange these terms. So I'm going to put 1.1 first. The next term would be 1.1 squared plus dot, dot, dot. N is 18. So the biggest the exponent is going to get is to the 17th. Okay, so here's my interest based on the $5,000 initial investment times 1.1 to the 18th. Then every year I'm getting I'm putting in $2,000 and I'm getting interest over the course of the 18 years. So 1.1 plus 1.1 to the second plus dot, 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 1.1 to the 16th plus 1.1 to the 17th. This is a geometric sequence. I said it wrong twice now. Geometric series. Okay, you can find the common ratio. The first term will be 1.1, and you can find the sum of 1.1 plus 1.1 squared plus dot 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 1.1 to the 16th, 1.1 to the 17th. So let's see. This here, my calculator tells me I get approximately this plus, okay, the initial term is 1.1. The common ratio is 1.1 because you see 1.1 times 1.1 is 1.1 squared. Okay, so let's see, guys. I'm going to do common ratio, and the number of terms, there's 17 terms in here. So let me just read this out. I think you can see this, but the 2000 stays the 2000 on the outside here. The first term is 1.1. I'm finding the sum here of this series, a number plus a number plus a number. Remember, a series is when you add terms together, so a number plus a number plus a number plus a number. So 1 minus 1.1 to the 17th divided by 1 minus 1.1. When you do this whole thing out, you get approximately, let me make sure you guys can see this, I'll put it over here. You should be doing this on your calculator too, just to make sure you can do it. So you get 89,198.35. So the total balance is $116,997.94. Although it's sort of unrealistic that you're going to be getting 10% interest. But who knows? Okay. Tough problem. Let's put on music for a minute. So no one, I don't know if anyone's going to get that singer, but I'm hopeful. Last one will be a little bit easier. The last one is a periodic sequence. If you look in the introduction to the notes, you'll see I give an explanation. But basically, it's a sequence whose terms repeat after a certain number of times. So let's just get right to this. General strategy is list out all terms until you see, this is just coming off the top of my head, until you see, see the pattern. So let's see what that means in 1 second. So let's see, guys. So we have a sub 1 is 2, a sub 2 is 3. Those are the first two terms. Let's find a sub 3. Well, a sub 3 is a sub 3 minus 1 over a sub 3 minus 2, which is a sub 2 over a sub 1, which is 3/2. So it looks like we're taking the terms before it and taking the term that's immediately before it and dividing it by the term that's 2 before it. So a sub 4 would be 3 over 2 over 3, which is, oh no, it's a half. And then a sub 5 looks like a third. So I'm just trying to write out all the terms. So let's go to a sub 6. I haven't seen a pattern yet. 2, 3, 3 over 2, 1 half, 1/3. Let's find a sub 6. So 1/3 over a half. That's 2/3. Let's find a sub 7. So that's 2. So maybe I've repeated. So it's possible that the period's 6, but let's find the 8th term. So if the 8th term is 3, we're pretty confident the pattern's repeated. Okay, so 2 over 2/3. That's 6 over 2. That's 3. Perfect. So it would seem like our sequence is 2, 3, 3/2, a half, 1/3. The period here is 6. So I'm going to have to extend the page here, but period is 6. So if we know the period is 6, my printer here, so scoot this up. Let me see. So if the period is 6, now we want to find a 2006. Okay? We want to find the 2006 term. Well, it repeats every 6 times. So if we take 2006 and divide it by 6, you could throw that into your calculator, but it goes in evenly 334 times. Well, I shouldn't say evenly, but it goes in 334 times with a remainder of 2. 6, technically. So the remainder, if you remember from polynomial division or elementary school, this is the remainder. So the remainder is 2. So to figure out what a of 2006 is, a of 2006 is going to be equal to a sub 2, which is equal to 3. So the answer to this problem is 3. Because remember, the pattern was 2, 3, 3 over 2, half, third, 2/3. So you go around 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 7, 8, 9, 10, 11, 12, 13, all the way to 2000 and I guess 2003, and then wait a minute. Yeah, the last, like for example, 2003 would end here. Let me think about this for a second. Yeah, 2 is the remainder. So you'd end here, and you're going to, I guess it would be 2004. The 2004th term would end here, and then you'd go 2005, 2006. So this would be your answer. So the answer for this problem is 3. Okay, guys, you're going to summarize, and I want you to, what were the key skills practiced today? Write that down on your notes, and one question you have after this lesson. That's not an example of a good question. Anyway.